Hope this went well for you. So number one, some fraction work up there. Do you guys do copy.flop right away?
Yes.
Okay. So if you did that, I think that's a good strategy. It'd be 3/7 times 21/4 minus 1/4. And then, to make this a little bit easier, did you guys do a little cross-canceling?
Yes.
Like simplify right away? You don't have to do it that way. But I'm seeing this 21 and this 7 could cancel to be a 3 and a 1 if you cancel out the common 7 factor. Then as we multiply, I just multiply my numerators together, my denominators together. That gives me 9/4 minus 1/4. And then, I already got a common denominator, so I can go ahead and subtract these. You guys get 8/4. And then that simplifies to be 2. All right, so again, just like we always do, look at what I have, look at what you have, and let's decide if we agree or disagree or close. Do you have any questions? Anything I can kind of reteach, help, review? Okay, fair enough. Number 2 says simplify completely. And whenever you're simplifying completely like this, you want to look for distributive properties first. Do you see any?
Yeah.
There is. Okay, what's being distributed? That's right. You guys said it right. It's -6 being distributed, not 6. So this would be 8 minus 6x plus 24. And then we got a whole bunch of other terms over here that may or may not be simplified down. Eventually, distributive property first. Did you guys get the plus 24? That's the one. If you're going to miss this one, that's usually where people go wrong. Hopefully that went well for you. Like terms, what is like the 3x squared? Nothing. I agree, yeah. Joe?
I just want to let you know that you put an addition symbol in front of the 7x.
Oh my goodness. Thank you. Did I say it right or did I say it wrong?
You said it right.
Isn't that funny how that happens? There we go. Thank you. Okay. So is there anything like 3x squared? You guys said nothing. I agree. 3x squared then would just be copied down into the answer line. What is like the -6x? That's right. That gives us -13x when you add those up. And then the only terms remaining are just all constant, right? So it'd be 8 plus 24 is 32 plus 2, 34. Any questions? Looking at what I have, looking at what you have. We good? Fantastic. Number 3. I mentioned this last time. Do you guys see how somebody could easily look at number 2 and look at number 3 and feel like it's the exact same type of question? Don't they have a lot of the same elements?
Yeah.
But what is the one element that makes number 2 totally different from number 3? Solve, because number 3 has, that's everything, right? If there's an equal sign there, that means one thing. If there's not, that means something else entirely. And so these are very, very different types of questions. The interesting thing, though, for number 3 is the first thing we have to do is actually simplify it before we can solve it. So there is a distributive property. What's being distributed?
Negative.
Yeah, -1 or just a minus sign, you could think of it. So this would give us 3x minus 7x plus 5 equals 6x plus 10. Are we all the way done simplifying? No. Did you guys add the 3x and the -7x first?
Yes.
I think I would do that first before I did anything else. Didn't have to be that way, but that's, I think, what I would do. Now we get to this interesting spot where on the left side of the equation there's an x term, and on the right side there's an x term. What did you guys do here? Go ahead, Carrie.
I subtracted the 5.
Okay.
Both sides.
Okay, subtracting the 5 gives us -4x equals 6x plus 5.
And then I subtracted the 6x on both sides too.
Okay, that works. So minus 6x from both sides. That would give us -10x equals 5. And then our final step would be to get the x all the way by itself. To do that, we need to do what? Divide by -10. So if I divide by that, do you guys get x equals -1/2? All right. Any questions? Again, looking at what I have, looking at what you have, are you showing good steps kind of like mine? They don't have to look exactly like that, but something like that would be certainly a good thing. Okay, and then lastly, number 4, listing domain and range. For my domain, I would have 6, 2, 3, -4, and 9. Of course, those are all the inputs or the x's. The range would be all the y's, -7, -9, and 6. A couple of those are repeated. You'll have to list them once. Any questions on A for 4? Okay, finally B. Function, yes or no?
Yes.
Yes. Okay. Anybody have an explanation? What do you think, Noel?
No input has more than one output.
Yeah, no, I like that. No input has more than one output. Anybody word it a little differently? You feel good about it? Yeah, Kyrie?
I said all inputs have their own output.
Yeah, there you go. Or exactly one output. Sure, yeah, that works. Anybody else? Got a little different wording there? Okay, fantastic. Any questions overall on the whole thing? Okay, beautiful. All right, so we're going to move on and we're going to do a little bit of graphing work here today. So if you guys would, flip over to here. I did hand some stuff out to each of your tables. Just leave those right there in a pile. We'll talk about those in a couple of minutes. Okay, so it's going to be all about graphing today. It's all about graphing this week, really. Just a quick note for you all. So today we're going to talk about graphing. Tomorrow we're going to talk about graphing. Wednesday we're going to talk about graphing. We'll have our DMR on Wednesday as well. On Thursday we're going to start our second project of the semester. It's a graphing project, an opportunity to be a little bit creative again and show that you understand some stuff about graphing and linear equations, slope-intercept form and point-slope form like we saw in the video. That make sense? Okay, so from the video I have a question for you guys. What are the two things that I have to have in order to find the graph of any line? There's only two things. If I know this and this, I can get that line graphed, no problem at all. What's one of them?
Slope.
What's the other one, Josh? Too specific. If I know the slope, and what's the other thing? It's sort of like what Josh said. He just was very specific.
The point?
A point. What kind of point? That's on the line. It doesn't matter where it is on the y-axis or the x-axis or whatever. If I know a point that's on the line, and it might be the y-intercept, could be, and I know the slope, I can graph this line no problem. That make sense? And in the video, you saw a couple of different ways to get the point, and basically one way to get the slope, I think. So if you would, let's take a look at number one. Let's do a couple of these together. Have you guys try some of these on your own. So it says graph using slope-intercept form. Hopefully from the video or maybe a past math class, you can look at that y equals 3x minus 8 and know that that's in slope-intercept form. What's the general form of slope-intercept form? Y equals mx plus b. And to maybe help us, I'm going to write that up here above. That might be a helpful thing to help us identify the slope in the y-intercept. So in this y equals mx plus b, what does the m always stand for? That's right, and the b stands for the y-intercept. So let's come on down here. Let's see if we can write this out. What would you guys say the y-intercept is in coordinates? Like something, comma, something? 0, -8. That's right. 0, -8 is your y-intercept. And so what I know then, that is a point on my line. It's not the only point, of course. There are infinitely many other points, but that's at least one of them. So I know half the stuff I need to know. The other thing I got to know is the slope. And in this case, the slope is 3. Good. So slope is 3. And if you maybe remember from a previous class or maybe, looking at the video, this maybe came to mind, 3 over 1 might make a lot of sense because slope, what's the meaning of slope? Yeah, Joe.
Rise over run.
Rise over run. Yes. So that means this line rises 3 and runs 1. Rises 3, runs 1. Okay, so here's how I would graph this. I'm always going to start by graphing the point that's on the line. So the point that's on the line is 0, -8. And so that would be right there. I'm just going to put a little dot right there. And then I'm going to count my slope off. And I'm going to count off my slope, rise over run, you said. Let's see here. This will be good. I'm going to actually try to show you my slope. I'm going to rise 3, and I'm going to run 1. Rise 3, run 1. Do you see that? Going up 3 to the right 1. And that tells me where another point is. And then, of course, I could continue on, do the same thing. I could rise 3 and then run 1. That shows me where a third point is. And I could just continue on to do that over and over again. Hopefully, I'd see the same pattern as long as I'm doing this correctly. Once I've gotten at least 2 points, I would then attempt to connect all those points. with a nice straight line. What always goes on the end of your line?
Arrows.
There we go. Got 2 arrows, and I got it. So what are the things you got to do? You got to make your points really clear. So I want to see some little dots right there. You don't have to label them and say, hey, this is 0, -8, and this is 1, -5, so on and so forth. To me, that's a little bit laborious. It can kind of make things a little bit messy. I want to see clear points where you have said it's here and here and here where the line goes. Any questions there? Vast majority of folks that have taken some kind of an algebra class have seen slope-intercept form, right? Okay. Joe, question?
Are you going to require us to label the points on the graph?
Label them as in 5,2,
Yeah.
7,6. No, but I do want to see dots. I don't want to just see a line with no points. The points are declaring, hey, it's here or here, whatever. I don't need to see labels, though. Okay, one thing I do want to see, though, did you guys notice my little slope count off there in orange? I want to see you counting your slope off. I think that could be a help to you, too. Okay, let's take a look at number 2. How many of you had seen that point slope form before? A couple of you, maybe 2, 3 of you. Okay, so let's review. Let's remind ourselves of this. In order to graph a line, what are the 2 things that I have to have? Slope and a point that's on the line. So with slope-intercept form, the point that you get is the y-intercept. With point slope form, the point that you get may or may not be the y-intercept, but it will be a point on the line. So let's see if we can interpret this. Again, this is from the video. Hope this all makes a lot of sense to you. Take a look at this y plus 4 equals -1/2 x plus 3. Can anybody identify the point that is on the line? Josh?
4.
So remember a point is something comma something, right?
Or 0, 4.
No, there's no, we don't know that this is any kind of a y-intercept. With slope-intercept form, if it's y equals mx plus b, then for sure, y-intercept will come out of that. Here it's not in slope-intercept form, it's in this point-slope form. Noah, what do you think?
Is it 3, 4?
Close, really close. She said 3, 4. In fact, that's close enough.
It's negative,
I'll write it up here, but it's what?
-3, -4.
Yep, you got to change the signs. Yep, you got to change the sign. -3, -4. So the x-coordinate is right there next to the x, and the y-coordinate's right there next to the y, but you got to change the signs in order for this to work. And you'll find that this pattern works no matter what you're graphing in this type of form later on. Have you guys ever heard of a parabola? Like a U-shaped graph? Same principle applies with how you graph that. Other graphs as well, you'll see as you move through math. Okay, and what's the slope for this one? Maybe this is a little bit easier. -1/2. So when you see -1/2, what is that equivalent to? So it's down 1, right 2. And that's what we want to be clear on. Let me write it out like this. Are you guys comfortable with the fact that -1/2 equals -1/2 or +1/-2? But it is not equal to that, is it? Right? So the negative, if it's a negative fraction, the negative either goes in the numerator or the denominator, but not both. Because what's a negative divided by a negative? That's different than, -1/2. Okay, so let me erase this stuff. I'll put this right here. I'll say this is my rise. This is my run. We'll get busy graphing this. So -3, -4 is my point that is on the line. So that's -3, -4, right about there. And then I'm going to count my slope off. My slope would be, if the rise is -1, that means down 1. Yeah. So that'd be down 1, right 2. You guys see my slope being counted off there, okay? So down 1, right 2. There's 1 point. Down 1, right 2. There's another point. Are you guys okay with reversing this? What's the same thing as down 1, right 2? Yeah, you can go up 1 and then to the left 2. So maybe something like that. Bottom line is, as soon as you have 2 points, you have a line And so I'm going to connect, or at least attempt to connect all those. There we go. And I put arrows on the end of my line. And I'm happy. Y'all have any questions? Okay, well, I can't remember. There might be one more example I want to work with you, but we'll see how this is all going. Oh, yeah, I do want to do this one. Okay, this is a nice connection back to Unit 1. Or not Unit 1, but earlier in Unit 2. So it says graph using slope-intercept form, and it says solve for y. So solving for y in a situation like this is something we've done. There's a question sort of like this that was on Concept Quiz 5. And so if you guys would, take a minute, see if you can do this on your own. Solve for y. 3x minus 2y equals 8. Ready, go. Number 1, graph using point slope form. Y plus 5 equals 3 halves times x minus 1. What is the point that's on the line? 1 comma negative 5. Do you guys remember to change the signs when you put it into that point form? Okay, so 1 negative 5 is right about there. And then my slope is what? 3 over 2. I agree. So my rise is 3 and my run is 2. So from that point, I'm going to rise 3. I'm going to run 2. That's really all I have to have. I could put some more points on there, but I don't have to. There's my line. And I put arrows on the end of it, and we're good. You guys have any questions? This one was actually numerically a little bit easier than the other one, wasn't it? The other one had some awkward numbers. Okay, any questions before we move on? Okay, then number 2 it is. So this one said solve for y, and walking around, I didn't get to every single person. I was very encouraged on your skills with solving for y. I thought you did a pretty nice job. So if we're going to be solving for y, the first thing I need to do is add 3x, right, to both sides. So plus 3x plus 3x. That gives me 4y equals 6 plus 3x. And my last step would be to divide everything through by 4. And when I divide through by 4, I get this. And this is where you guys, and I understand why, started feeling a little awkward about this. You're like, whoa, what's going on here? There's an awful lot of fractions. And I'm not used to having a lot of fractions in this situation. But we can still decipher this. Do you guys recognize that mx is really 3/4 x on this one?
Yes.
So doesn't that mean that your slope has to be 3/4?
Mm-hmm.
Okay, so there's your rise, there's your run. But we also have to have the point that's on the line. And in this case, the y-intercept is a nice, convenient one. Can I just give you guys a hint about this? Hopefully this will be helpful. Isn't your y-intercept always 0 comma something?
Yes.
So if you're ever struggling, at least go 0 comma I'm not sure yet. And then maybe we can figure out the I'm not sure yet part. Did you guys notice that your b was right here?
Yeah.
What was so weird about your b?
Fraction.
Man, we're not used to that, are we? We're used to that being a nice integer value, and often it will be that. This time it just happened to be a fraction, not a too scary of a fraction. What's 3 halves really in decimal form? Yeah, it's 1.5. So I'm going to start off by locating that. So 0 comma 1.5 would be roughly halfway between 1 and 2. And then from there I'm going to rise 3 and run 4. So I'm going to rise 1, 2, 3, and run 1, 2, 3, 4. So that would put me right about there. Again, halfway between 4 and 5 at that spot. Connect those two. Arrows. Done. Okay, any questions? Anything I can do to help? So one thing we'll want you to do, like when we get to, I don't know, like a concept quiz, maybe some DMR quizzes where we're doing these graphing of lines, is we're going to want you guys to use a straight edge. Just a matter of like personal pride in the way your work looks. And so I've got quite a few of them. I probably have at least a dozen, 15, 16, something like that. But if you have a straight edge, it's just like something you keep in, like a ruler or whatever, like in your locker or your notebook. Just start bringing those, and so that when you graph a line, you can just line things up and have a nice straight line. It's always good. Okay, any questions about anything we've done today? Okay, so at this point, if you guys would, please take these little papers that I passed out to your table and pass those around to everybody.